So the whole point of learning the power property is to solve questions like number 4. Question number 4 is an equation that we want to solve for x. And the first thing we want to do is to just try to use a little bit of common sense to see if we can predict a little bit about the answer, and then we'll narrow it down from there to see if we can get a little bit closer to precise answers. Now, just to kind of get a feel for things, I'm going to look at this equation first with a critical eye and realize that the logs aren't really the part of the equation that I want to solve. Mostly because if solving is all about making the left side match the right side, well, I already have a log on the left and a log on the right, so the logs aren't really going to do much for me. I want to focus instead on this 2 to the power of x and the 25 to help me get a sense of what's going on here. 2 to the power of something is going to have to give us 25 as an answer. Now, I know this isn't going to be a nice answer because 2 is an even number and 25 is not, which means 2 to the power of something is never going to give me an odd answer. So the best I can do is try to narrow it down a little bit. 2 to the power of something is going to have to get me close to 25. What could get me the closest? 2 to the power of 1 is 2, very small. 2 to the power of 2 is 4, pretty small. 2 to the power of 3 is 8, still small. 2 to the power of 4 is 16, still small. 2 to the power of 5 is 32, too big. So now all of a sudden I need to think about it. 2 to the power of 4 was 16, and that was too small. 2 to the power of 5 is 32, and that was too big. So in a kind of Goldilocks sort of way, I need to assume that the sweet spot that I'm looking for has to be somewhere between a power of 4 and a power of 5. 2 to the power of 4 was too small, but 2 to the power of 5 was too big, and that means that x, whatever it is probably some sort of decimal between 4 and 5. So in that first part, part A, where it says the value of x is between what two integers? Integers are whole numbers. We know that x is between 4 and 5. Now to narrow it down specifically, we have two choices. First option, you can guess and check. You can do 2 to the power of 4.1, 2 to the power of 4.2, 2 to the power of 4.3, 2 to the power of 4.4. And you can just keep guessing and guessing and guessing until you get close to the number that you want. That works. If you have a calculator, it works really well, but for some people, guessing is a real exercise in patience, and I'm not necessarily sure that everybody wants to do it that way. So if you're not really into the idea of guessing, here's what we can do that invokes that power property. Remember how we said that the whole reason we learned the power property is so we can solve problems like this? Here's why. Check out the left-hand side of the equation. I copied the equation down in my workspace here so you can see it. But notice on the left we have that power of x. That's a power in a log problem, which means it can move down to the front. The x is movable. Anytime you have a power in a log problem, it's movable. You can move it down to the front. If I move it down to the front, it becomes x times log 2. Now I don't have anything to move on the right hand side, so I'm not going to bother. I'm just going to call it equals log 25 again. But notice something. Remember how we wanted to get x by itself? We wanted to solve for x. Now all of a sudden our algebra brain can kick in a little bit. X is just multiplying something. I know how to get rid of multiplying things. If I want to get rid of multiplying things, I'm just going to divide them. So I'll divide whatever log 2 is. It's awkward to divide by something like log 2 because we don't really know what that is yet. But notice if we just go through the motions, the log 2's cancel, and x is by itself. That's what we wanted. X is now equal to, and then I have this weird fraction, log 25 over log 2. That does not look like an answer, but it's actually something a calculator can handle. If you have a standard calculator of any sort, whether it's graphing or not, it should have a log button. As long as your calculator has a log button, you can do this calculation. My calculator, for instance, has a log button right down here near the 7. Even most phone calculators have a log button. Sometimes you just have to find it. For instance, on my calculator, which is an Android version of things, if I rotate sideways, so that I get the bigger scientific screen, I can see the log button appears in the buttons on the right hand side. If you don't have that scientific option, or if you're on screen lock or something, sometimes you'll have like a little extra arrow key that allows more options to pop up. So explore your phone calculator if that's all you have, because it may be that it has a log hidden somewhere. Another option is to just go to Desmos, desmos.com/calculator, because you can actually just type the letters LOG and it works like the log button in the calculator does. In any case, I'm going to type this thing into the calculator. So I'm going to type log, so notice as it appears on my screen, 25. Then I'm going to close the parentheses. By default, the calculator opens parentheses when it wants me to show what's inside of that log. So I type the 25, then I close the parentheses. Then divided by, because that's what we wrote. Then another log, and then 2, close the parentheses. Now I'm going to get an answer. Looks like a decimal. It's super ugly, 4.64. But notice what I've done here, 4.64. I've got an answer that's between 4 and 5. Remember how we said that we were expecting an answer between 4 and 5 over here in part A? We got an answer that was between 4 and 5. That's exactly what we expected. So solving with logs actually got us to the correct answer, and we didn't have to guess and check anything. The key was using that power property. And although I didn't write it in the box, the key was doing this step here, taking the x from the original problem, which used to be an exponent, and bringing it down to the front so that it became a standard multiplication. That means the problem turned from, oh my gosh, this has an exponent, I don't know what to do, to, oh, multiplication. I know what to do. I've done lots of multiplication problems. I can just divide it and get rid of it and be done. So that's the beauty of the power property. It allows us to basically divide whatever's going on, and in our calculator, it allows us to type in that division in a way that our calculator can totally handle. So the moral of the story is you will need a calculator to be doing these problems, but the calculator is going to do the vast majority of the work for you. Take a second to just see if these steps make sense, because in the last video, we're going to do question number 5 using these same steps. If the steps don't make sense yet, rewatch the video or take some time to look at the answer key and wrap your head around it first before trying to build on it anymore in question number 5.